Okay, so to me, this language is regular. It is also given in the pumping lemma preliminaries. A, B length than A is regular, even though N is unbounded. Huh? Yeah, this language it is regular. So we are trying to, I've not mentioned anything here. So we are trying to find out whether this language is regular or not. Okay. Okay, so we always start writing like this. Let the string is equal to a, b, length and a, which can be written as xy, length I, z, where I is greater than or equal to 0, is an element of L. That is, whatever we get as string here will be a member of the given language. Okay? And we assume it to be regular because we are saying let. So when we say this, we are assuming this language to be regular. And we are going to find out using pumping lemma whether this language is regular or not. Okay. So as usual, we have to do the splitting. And we have to remember these two conditions. In the exam, these two conditions will not be given. You have to remember. Okay. It's very simple, nothing difficult to remember. We have to remember this. Length of xy is less than or equal to n, and length of y is greater than 0. Okay. So here, we are going to split this language in terms of x, y, z now, applying these two conditions. Usually what I do is I always go to y first. Why I go to y first means because of this condition, y must be greater than 0. Length of y must be greater than 0. Length of y must be greater than 0 means y cannot be empty. Okay, y cannot be an empty string. So it has to have at least one letter, right? So, and x and y together should be less than or equal to n. Okay, so here you have to be a bit careful while you do the splitting. I cannot take y as simply b length n minus k, because normally we try to follow what we do here, right? B power k, right? We put b power k, we put a power k here, right? We cannot do that here, I will tell you. We cannot follow this this style. P power k, and we here we write a power n minus k. We cannot do that. I'll tell you why. If we write like this, we won't get a, b length n. We cannot write like this, because if you write like this and we put z as a, if you take k as 1, right, n is 1, k has to be less than or equal to n. So k cannot be 1. If k is 1 and n is 1, 1 minus 1 will become 0. A length 0 will become empty. So we cannot have anything here. So if k is 2, n can be 1. But here, it is only a alone, right? So we cannot write like this. So we have to, no choice, we have to write like this. Okay, so we split like this. But again, we have to be careful. When we write like this, what happens? You see the condition now. Length of xy must be less than or equal to 1. Sorry, n. So what is our xy here? Xy is equal to, in our case, a, b length n. A, B length n. It says xy must be less than or equal to n. It satisfies, right? Satisfies, does not satisfies. Give a value for n as 2. If you give n as 2, what will happen? What will be your string? If n is equal to 2, what will happen to our xy? Our xy will be equal to ABB. Sorry, ABB. Oh my, ABB, sorry, ABB. Because A followed by B length 2 for ABB. So what is the length of your string now? 3 letters. Okay. But here we are saying length of xy must be less than or equal to n. N is only 2. So your length of xy must be equal to 2 or should be less than 2. In our case, it becomes 3. So what I'm saying is we cannot take y as b power n as well. Okay. So what we need to do, we need to take b as n, sorry, b length n minus 1. So if we take b length n minus 1 and n is 2, then it will work. Okay. So we have taken it as n minus 1, right? So what will happen now? It will become n is 2 means ab length 2 minus 1. 2 minus 1 is 1. So you will get ab alone. So you get back your xy. That is, your xy, length of xy is less than or equal to n. Understood? So we have to take x as a, y as b length n minus 1, z as a. So now we have done the splitting correctly following these two lemma. Our length of xy will be less than or equal to n because x is a, y is b length n minus 1. So if you give n as 2, you will get a followed by b power 2 minus 1. B power 2 minus 1 is b power 1, b length 1. So ab. So what is the length of ab? 2 letters. So your xy length is 2, your n is also 2. So it satisfies the condition. Length of xy is less than or equal to n. In our case, length of xy is equal to n. That is 2 letters. Okay, our splitting is correct. So now we can do the pumping. No need to say pumping y. When you say x, y, y, z, mathematically, you are already saying that you are pumping y. That is, you are repeating y one more time. Y means, don't forget, we made an assumption here. When we say let, we are actually saying let us assume. This means let us assume the string is equal to a, b, length and a, which can be written as xy length I z, where I can take a value greater than or equal to 0, is a member of L. And we assume that this language is regular. Okay, so we are already taking the language as xyz, and we have split the language in terms of xyz. So when you say xyz, you are already saying, or we are already saying that we are pumping y one time. If you say xyyz, we are pumping y 3 times. You are repeating y 3 times. Okay, so if you are pumping one more, then you are repeating y 4 times. Okay, in xyz, y is repeated only one time. So now when you say pumping y, you are repeating one more time. Okay, so we just copy this here. X means a. Okay, what is y? B length n minus 1. What is y one more time? B n minus 1. What is z? Z is a. So this is equal to a. Yeah. So now how to equate this? B n minus b power n minus 1, b power n minus 1. How to rewrite this? Anyone? Anyone? How to rewrite this a followed by b length n minus 1, b length n minus 1, a. Anyone? No one. Hello, keeping quiet. Okay. You are correct. I'm just reading your message in the chat. You will be ending up as A. Let me type it here. You will be ending it as A, B, length 2n minus 2. Uh, Correct, right? Yeah. Actually, this is same as. I'll tell you why. I'm saying AB length 2n minus 2 because it will be B length n minus 1 plus n minus 1. N minus 1 plus n minus 1. So that will be 2n minus 1 plus minus 1 will be minus 2, right? Yeah, 2n minus 2. What you have given in the chat is correct. So your confusion is how this boils back to AB length and A. This is the same as AB length and A. Why means in our case, in this particular question, n has to minimum 2. If n is 1, in our case, in this case, n has to be minimum 2. If n is 1, why I'm saying minimum 2 means if n is 1, 1 minus 1 will become 0. Then it will become B length 0. B length 0 means y will become empty string. Here, the lemma says y has to be greater than 0. So minimum value n can take in our case is 2. Okay. So if you take n as 2, it will become a, b, 2 times 2 is 4. 4 minus 2 is 2. Correct, right? Yeah. So if you look at what is the example string here, example strings are ABA, ABBA. You can have any number of B's, right? Yeah. Same thing here. So 2 times 2, n is 2. So 2 times 2 is 4. 4 minus 2 is 2. So A, B, 2, A. A followed by B, 2 times A. Sorry, B 2 times A. Okay, if n is 3, what will happen? N is 3 means it will be 2 times 3, 6. 6 minus 2 is 4. right? So you can have any number of B's, does not matter. So after pumping Y one or more time, you will actually have, any number of B's. But in the front, you will have only one A. Towards the end, you will have only one A. Okay. So your resultant string after pumping one or more time will be still in this language. Okay, here the language is A followed by any number of B's followed by A. So you pump one time or two times or three times, this property of A followed by any number of B's followed by A will not be lost. So A length, B length A is actually regular. Okay. So what is the chat in the question? If yes, that's why I said if n is equal to 1, you will get 0. You cannot get AA. You cannot, because that's why I'm saying here in this case, minimum n has to take a value 2. Okay, minimum n has to take a value 2. Because if n takes a value 1, b length 1 minus 1 will become b length 0. Because your lemma says y has to be greater than 0. So n cannot take a value 1. Minimum value n should take is 2. Okay, yeah. Okay, yeah. Yeah. Any other question before we leave? The question best, yes, but the question allows n is equal to 1. Okay, I understand. So what we usually do is whenever we go for the pumping, I use a different variable. I don't use the same variable here. Usually, a lot of literature you can say they use the variable p minus 1. Instead of n, they use the p so that you don't confuse with this variable. Here we are using the same variable. That's why it leads to confusion. Yeah. So you should take it like this. If you take a different variable, it won't be confusion. Okay. Yeah. Why we use the word P means P stands for pumping length. So how many times you can pump Y? We can pump Y one or more times. That's why we use the letter P here. I know for some questions, this we use the letter N here. It overlaps with the N here. So I mean N here. So so this confusion arises. So we should take it as P pumping length. Then this confusion is avoided. Yeah. See, what the pumping lemma says is after pumping Y, whether the resultant string, the string that we get after pumping Y, is in this language or not. So if you see after pumping Y here, okay, the original property of the language is not lost. You still get one time A, you still get one time A, one A as prefix, one A as suffix, and B can be any number of times. Okay, so the original property of the language is preserved. So that's why we say this language is regular. So if we use P, should we also specify the range? Yes, we have to specify the range like what we do here. See, we specify the range. Why we specify the range here means we specify the range because to ensure that y is not equal to 0. Because the lemma says length of y must be greater than 0. So that's why we are saying here what values k can take. Okay, yeah. So in our case, we have to say what values p can take. Okay, it is understood what values p can take. So what values p can take here? P should be, we decide what values p can take to ensure the lemma is satisfied. The lemma says length of y cannot be equal to 0. Length of y cannot be equal to 0. So length of y must be greater than 0. So if p is 1, 1 minus 1 will become 0. So y will become 0, right? So we have to specify what values p can take. So p has to be P has to be greater than 1. In earlier cases, we took K as greater than 0. You see, K as greater than 0, less than or equal to N. So in this case, in this particular case, P has to take a value greater than 1, but less than or equal to N. So we are taking, yeah. That's why we are taking P as 2. Your N can be 2. N can be more as well. If we pump Y using the power Y, but it also says Y is greater than or equal to 0. So if you don't pump Y, meaning I is equal to 0, that isn't part of the language though. We pump Y using the power I, but it also says I is greater than or equal to 0. So if we don't pump Y, meaning I is equal to 0. Oh, what this means is the language is of the form xy length I z, where I is equal to 0. This is correct. But when we split the language, you shouldn't confuse between splitting and this language format. This is language format. Okay. So here the lemma says when we split in terms of x, y, z, y cannot be equal to 0. Because it says y cannot be equal to 0 means it want to see by pumping y, is there a loop or not? Okay. If you see the regular languages, somewhere there is a loop. That's why we cannot say strictly by looking at boundedness that a language is not regular. There are languages that have unboundedness, but they fall into regular category. Okay, there are languages that have unboundedness which fall under not regular category. So we cannot simply blindly conclude if the memory needed is unbounded, the language is not regular. There are cases where unboundedness also lead to regular language. So the experience is when we see that there is somewhere a loop. That's why the pigeonhole principle comes. So how to verify whether the language has a loop or not? That's why the pumping theorem comes. So when we pump, we are seeing whether the loop is there or not. If there is a loop, then when you pump, the original property of the language will not be lost. Okay? When you pump, and if the resultant string is still in the language, it means there is a loop there. Okay? That's why the original property is not lost. If you pump and the resultant string is not in the language, then it means there is no loop in the language. Okay? If there is no loop, then automatically the original property will be lost. That's why in the lemma, the condition puts y must not be equal to 0. Okay, yeah. Okay, yeah. Yes, it's a very interesting topic. I know it's a lot of question comes whenever I teach pumping lemma. Okay, so don't worry, it's normal. A lot of question comes. Yeah. So there's another one, A, B length and A. Things are A, B, A. I understand what you mean by this, Tan. Oh my God. Okay, to answer Tan this one, even you change this as greater than or equal to 0, it does not makes any change, So in this case, your minimum string is ABA. If you change this as this, only change that is going to happen is example string is going to be AB. That's all. Still, this language is regular. There's this. I know you are picking up here. I put greater than 0 here. I'm putting I is greater than 0. That's why I said this is the format. of a language. So even I change this to tally, this also equal, greater equal to 0, this also greater equal to 0. Your example string is going to be AB, that's all. One more string you're going to add, that's it. So this does not changes this language to be not regular. This is still regular. So n can take a value from 0 to infinity. So you will have AA, AB, sorry, not AB. I'm sorry, AA, ABA, ABBA, and all so on. Because the language is still regular. So the unboundedness is only here. We are only looking at unboundedness. That's all. Unboundedness means it is going to the maximum value is infinity. Yeah. So maximum value is infinity. So unboundedly the memory is going to grow. Okay. So your stack can actually theoretically can grow infinitely long. Yeah. This is what I explained in class. This is taught in operating system. So your memory, how big? I'm answering your. You put a copy paste text right in your chat, showing that you showing that here I am putting greater than or equal to 0. Here I put greater than 0. Right. So I'm explaining this. When you do this, you can change this to greater than or equal to 0. Also, it does not make any difference. It is that this language is still regular, whether n is greater than or equal to 0 or greater than 0. Okay. So if let us keep the question as it is. Even you put greater than or 0 here, we still have to take y as b length p minus 1, where the minimum value p can take should be greater than 1, because we cannot take it as 0. Yeah. Why we can't take it as 0 means we are satisfying the lemma. Shouldn't confuse the lemma with the language. Yeah, the lemma talks about splitting, how you can split the language in terms of x, y, z. Okay. As I said, why it says y cannot be equal to 0 means it want to see whether there is a loop in the machine or not. Okay. So it want to see by doing the pumping. That's why I said by repeating y, if the resultant string, it is still in the language, the property of the language is not affected, then, it means there is a loop somewhere in the string. Okay. Yeah. So it takes advantage of that property. If the loop is there, then the language should be regular. If the loop is not there, then the language is not regular. That is the idea behind the pumping lemma. So can I have a look of example answer for what? Which example answer? Which question you are asking for example answer? Law Kok Chong. 4.1 example A. 4.1 example A. 4.1 is here. It is there on my times also. This example question is always solved. The answer is there. Yeah. So any other question before we leave? Is already 12:30. Some of you may feel hungry. The recording will be automatically available in the chat. Yeah, be automatically available in the chat. Maybe I can take the link and put it in the my times also. So if you go to your Teams, you can see in the chat the recording will be there. Additionally, I can take the link of the recording and put it in my times also for easy reference. I can do that. Okay. Yeah. In the tutorial PDF, what is the range of M in question? Good question. I'm sorry, mistakenly closed it. You're asking, let me share again. So you're asking about 4.2D, right? Okay. Range is missing. Okay. So good question. Yeah. I've included the range now. M should be greater than 0. M is greater than 0. So this means A is 1 time means B will be 3 times. Okay. A 1 time means here, the example string A 1 time means B will be, M is 1. M is 1 means B will be 1 plus 2. Like this. 2 times means 2 plus 2. So 4 times. Like this, etc. This is a pattern of string. All these languages are to me not regular because you will be splitting your xy here. Here also you will be splitting the xy here. Here also you will be splitting the xy here. You will be splitting the xy here. So when you split the xy here or here or here or here, the original property of the language will be lost. Okay, so it will definitely be not regular. Yeah. Any other question? Yeah. If no other question, then thanks for joining me. So next week, again, in the tutorial class, lecture class, you have any doubts, you can still ask me, no issue. Okay? Yeah. So thanks for joining me. There are already a lot of people left because it's 12:35. Maybe they're hungry. Yeah. Thanks for joining me. So I'll catch up with you all in the next week. So any doubts, please feel free to ask me during tutorial class. As I said, week after next week onwards, every Saturday I will open 1 hour. We can even sit for 2 hours. So anyone can join online and clarify any doubts you have. Okay. Until the exam, until the last week of the semester, we will do that. Okay. We'll do it as a consultation class. Okay. Thanks, guys. Have a good weekend. Good day and a good weekend. Bye bye.